We are using Floodlight controller as our OpenFlow controller and Mininet as our network emulation software, which would instantiate all the OV switches, which in turn the topology can be constructed using the same. I would now go ahead and start Floodlight controller. Right now we are using a topology where there are 4 switches and 4 hosts. The 2 hosts are connected to S1 and 2 other hosts are connected to switch 4. I'll go ahead and start the topology now. So through UI we could check the topology. So this is the topology that we've got. So this is switch 1, this is S1 with 2 hosts, and this is switch 4 with 2 hosts in the respective switches, switch 2 and switch 3. Since we've not pinged any of the hosts now, essentially the flow bases at the respective switches would be empty. So this is switch S1 where you can see there are no flow entries are empty. This is switch 3 and this is switch 4. We have 4 important components in our demonstration. One was the Floodlight controller, the other one is a Mininet we have in control application, and one more is a deep packets inspector, which is a snot. We are using snot as our deep packet inspector. So basically through our controller application, a user or an operator would come and configure the host or the users into respective classes. So currently for this demonstration we have taken H1 as gold user and H2 as a silver class user. So now I would go ahead and demonstrate it through the application. So now I would go ahead and ping between H1, ping H3, so as you can see now, a ping between H1 and ping H3 is happening due to the installation of the flows. So basically what happens is, soon after H1 ping H3 has happened, there were no flow entries before the ping. So now soon after the ping, it contacts our controller application. The controller application in turn would install all the rules in snot according to the user classes. According to these users, the controller application will go ahead and install the flows. So basically here, since H1 is a gold user class, the control application would go ahead and install the root as switch S1, switch 2 and switch 4. So gold user class would be any of the advantages, like bandwidth would be assigned more for this particular user, gold user. So all the configuration would be stored in a database which is maintained in the controller application. Since we've pinged H1, ping H3, this would have installed the flows. The flows have been installed by the control application in the respective OV switches instantiated by the Mininet. As you can see, these are the flows which are installed in the respective switches. So the gold user root is switch S1, as I've showed you, switch S1, switch S2 and switch S4. So now switch S1, switch S2, we have the flow entries here. Switch S4, we have the flow entries here, but switch S3 will not have any flow entries because the gold user has not been assigned this particular route. So now as you can see, in switch S3 there are no flow entries. So this is how dynamically the flow entries would be installed according to the user class, could be gold user or a silver user. Now I would go ahead and demonstrate for the silver user. Now H2 is considered here a silver user, where where after the details have been received by the DPI inspector through the controller application that this particular user is a silver class according to the database which has been maintained in the controller application. Now I'll go ahead and so now I'll ping h2 ping h4. So if you see here, ping between h2 and h4 is working here. So essentially, depending on the rules installed in the snot by the controller application and the database configuration in the control application by the user or an operator, as decided that since h2 is a silver class user, would be taking the route s1, s3 and s4. So the same could be checked through the flows that have been installed by the controller application in the respective switches. Before we had two flows in switch S1, so now we would have four flows because same H1 and H2 is connected to switch S1, S1 and S4 would have four flows in turn. So now switch 2 wouldn't vary because there wouldn't be any flow increase because this silver class user has taken the route S1, S3 and S4. S2 is not part of the route. So the real difference would be here where switch S3, which was not there before, now has the route since it is part of the flow now. Switch S4 essentially there would be increase in flows, like there are flow increase as S1 what I showed you before. So this is how our application mainly determines according to the classes, and this could be configured through a database at the user level or at the operator level which is running on the controller application. Now I would show you the snot, which is our DPI application which is running in other systems. So we've taken the snapshot of snot running. So we have this is the snapshot of where snot is running. As you can see, snot version 2.9.2. this is an DPI open source DPI application, and the rules which I was talking about are these rules. As you can see, a user could configure in the snot as rules where when h1, which I told you is who is a gold user, and h2 is a silver user. So when we ping 10 dot, that is h1 to h3, the snot in its rule understands that he is a gold user, would in turn communicate back to our controller application which informs that h1 is a gold user. So install a path which is specific to this particular class, with which the controller application will go ahead and install in respective switches. Similarly, one for the silver class, so 0.2, that is h2 ping h4 would instantiate this particular rule which is given an unique IDs for each and every rule here. This not application would in turn communicate back to the controller application, which with the application would understand that h2 is a silver user and would install that particular route which I showed you before, that is switch S1, S3 and S4 according in individual switches where the flows have been installed here.